these two Chinese bowls here. Got a Chinese design along the edge. One of them, they're both upright. We're going to turn this one upside down. This bowl has a concave shape. Concave, like so. The other bowl has a convex shape. This bowl will hold water. This bowl will not hold water. If you pour water into this bowl, it'll stay. If you pour water here, it will just make a mess. Now we need to understand clearly the difference between concave and convex. It's critical to understanding what is going to be presented right now. If we look at Jupiter, we will just have Jupiter out here. We'll have the sun over here somewhere. This is not drawn to size, obviously. Jupiter has 4 satellites that are orbiting around itself. Jupiter is the parent planet to 4 satellites, 4 fairly good-sized satellites. Jupiter actually has quite a few more satellites than just 4. Now, in a previous video, Twin to the Sun, the True Nature of the Moon, I discussed this in some detail. However, just briefly restating it, we have some missing real estate in our solar system. There are 4 planets in the inner solar system that are missing. Every time you see a shooting star up in the sky, you're seeing a piece of one of those missing planets that was destroyed a few thousand years ago during the solar system catastrophe, which you've never heard of, but the solar system catastrophe is the same thing as Noah's flood. Noah's flood was a far bigger and more consequential event than it is given credit for. So Jupiter has 4 large, what I call creation satellites. Jupiter has dozens of other satellites that are rubble satellites, that are pieces of these missing planets that were floating through space, and Jupiter managed to snag them by its strong gravitational influence and force them to orbit around itself as one of its satellites. Johnny-come-lately satellite, I think of them as. Well, if you look at this diagram here, what I want you to understand is that this part of the orbital path of each one of these satellites is concave towards the sun. This part of the orbital path of these satellites is convex towards the sun. The concave part is hollow towards the sun. The convex part is bulging out towards the sun. Jupiter, as it orbits the sun, drags its family of satellites along with it. These satellites are not orbiting the sun directly. They are, however, orbiting the sun indirectly, given that they are forced to go along with Jupiter. The sun and any planet that has satellites are engaged in a constant tug-of-war for control of those satellites. Now, the sun is by far the most massive object in the solar system. In fact, the sun all by itself possesses 99.86% of the total mass of the solar system. In other words, the sun, for practical purposes, is the solar system. All the planets and satellites and space rubble only accounts for 14/100ths of 1% of the entire mass of the solar system. So who wins in this gravitational tug-of-war between the sun and the planets? Well, that depends on 2 factors. One is the mass of the 2 objects that are pulling on the satellites. The sun, obviously, in point of mass, is going to win every time. Even mighty Jupiter, as big as it is, the largest planet in our solar system, is far, far smaller than the sun, about 1,000 times smaller in terms of mass. And so there is another factor, however, that enters the equation, and that is What is the distance from the center of Jupiter to the center of the satellites that orbit it as compared to the center of the satellites to the center of the sun? And in this regard, Jupiter wins overwhelmingly over the sun. So much so that in the gravitational tug-of-war with the sun, Jupiter handily outpulls the sun for control of its satellites. Now, if we look at the satellite system of Saturn and look at the innermost satellite, which is Mimas, Mimas is pulled by Saturn 25,000 times more strongly than the sun. If you go out to the final, what I call creation satellite of Saturn, Iapetus, there your tug-of-war ratio is 45-1 in favor of Saturn. So you see, the farther that you get away from the planet, the less favorable that ratio is to the planet. But still, 45-1 is good enough to keep a firm grip on Iapetus. It's not going to detach from Saturn under those circumstances. The tug-of-war between the Earth and the sun for control of the moon, however, is an entirely different situation. One that I have found from having made my way through approximately 3,000 astronomy books, that there are a fair few astronomers who very obviously do not understand what's going on with the moon, the earth, and the sun. I said there are a few, there are some. I think the majority of astronomers do understand, but I've seen some very bad illustrations and some very misleading text that makes very clear that this is not correctly understood by all astronomers. So if we look at the case of the sun, earth, and the moon, we're going to find a very different situation. What we find with the sun, earth, and the moon is that the gravity pole ratio, the GPR, the gravity pole ratio between the sun and the earth for control of the moon is slightly better than 2 in favor of the sun. In other words, the sun outpulls the earth for control of the moon by better than 2-1. Therefore, the moon owes gravitational allegiance first and foremost not to planet Earth, but to the sun. Now, here on planet Earth, we're accustomed to thinking of the moon as a satellite of Earth. But if you read through a whole lot of astronomy books, as I have, the astronomers know perfectly well that the moon is a true planet of the sun, that the Earth and the moon constitute what is called a binary or a double planetary system. The moon serves, as it were, two masters. I like to think of the moon as a child that has a strong father and a loving mother, and it faithfully obeys both of them at all times. And so the strong father to the moon is the sun, and the loving mother is the earth. And the moon is under the gravitational influence of both of them, but it is more strongly influenced by the gravitational pull of the sun than it is by the earth. The result is that the moon and the earth going around the sun as a pair have a very intricate orbital dance that they perform. It is difficult to do a proper graphic of it, but what it comes down to is that the orbital path of the moon in respect to the earth is concave at every point. But that is also true for the moon in respect to the sun. So unlike the satellites of Jupiter, Saturn, Uranus, and Neptune, which spend half their time concave in respect to the sun and the other half convex in their orbits in respect to the sun, that is not what the moon does. The moon is always concave at every point in its orbit, both to the sun and to Earth. And this principle is one that you will have to study out a bit. I have adequate material in my book on Earth's little brother to make this point, I think, very, very clear. So the moon and the Earth have an interesting relationship that the astronomers have noticed, and they comment on it. In the solar system, there are 6 satellites that are roughly the size of the moon. 4 of them are satellites of Jupiter. 1 of them is a satellite of Saturn, Titan by name. The moon is the 5th largest of these 6 large satellites. What is interesting is that these 6 large satellites are compared to their home planets, with the exception of the moon, are rather small. Jupiter, Saturn are very large planets, and their satellites are dinky little things compared to their home planets. This is also true for Uranus and Neptune. However, with the Earth and the moon is roughly 1/4, a bit more than 1/4 the size of the Earth, and is roughly 1/80th the mass of the Earth. The result of that is that the moon and the Earth have a point that is located between them. It is always facing the moon. It is about 1,000 miles under the crust of the Earth. It is in constant motion, and it is the barycenter. If you think of a teeter-totter or a seesaw at a playground, and you have 2 children of unequal sizes, and you have a large child on one end and a small child on the other end, you will have to adjust the teeter-totter board so that the board plus the small child is roughly equal in weight to the shorter end of the board and the large child. And this is what we have with the barycenter. The barycenter, again, is located 1,000 miles beneath the crust of the Earth. The moon orbits this barycenter roughly every 27 days. The Earth also orbits that barycenter, so that if you picture the Earth roughly 8,000 miles in diameter, and under here about like so, you have the barycenter. This is the moon, by the way, originally giving off its own heat and light. You have the barycenter here. The Earth is actually rotating, the entire planet is rotating around that barycenter. It is orbiting that barycenter. So the Earth does a wobble around that barycenter every 27 days on its way around the sun. But this represents the moon here. Another point that we wish to mention is the satellites or the planets of the sun, rather, orbit the sun in a counterclockwise manner. And they all orbit the sun from basically what is called the ecliptic. The ecliptic is kind of the general orbital plane that the planets are in, going around the sun. There's a little bit of variation. Originally, there was no variation, that the ecliptic, the orbital plane, was the same for all the planets, but we had some pretty violent adjustments to the solar system during the solar system catastrophe a few thousand years ago, and the perfection of the system is not currently reflected in what we are living with now. But when the Earth tipped on its axis by 23.5 degrees, because we are tipped, the moon continued to orbit the sun on the ecliptic. It did not tip along with the Earth. This is a major clue that the moon is a planet of the sun. It is not just merely a satellite of the Earth.